Welcome to today's Explainer. We're diving into something super exciting today. We're talking about flipping the script. How do you go from just being a passive consumer, just playing digital games and watching animations, to actually creating them yourself? Well, we're going to unpack a really fantastic chapter from the Kaushal Both Grade 6 curriculum called Animation and Games. It's essentially a step-by-step guide to demystifying the magic behind our screens. By the end of this, you'll see exactly how creativity and tech blend together to literally bring your ideas to life.
Here's our roadmap for today. First, communicating with computers. Second, visual programming with Scratch. Then, designing your game. Fourth is coding, testing, and sharing. And finally, health and screen time. Let's get right into it.
Section 1. Communicating with computers.
So before we even think about opening any software or writing a single line of code, we really need to get a handle on digital communication. The chapter actually kicks off with a super direct question in its first activity. Why do we play games? I mean, really think about that for a second. Sure, we play them for fun, right? For the challenge, maybe the stories. But by asking this right out of the gate, the textbook pulls you out of that passive player mindset and forces you into the active, critical mindset of a game designer. Because, a truly great programmer always starts by understanding the user's experience.
And when we bridge the physical and digital worlds, things get really interesting. Think about outdoor games like cricket or blind man's buff. Now compare those to indoor games like chess or Ludo. What do they actually have in common? Well, if you really break them down, they all have rules. They all have characters or players. There's always a background or a field of play, and they completely rely on interactions. The core lesson here? All games, whether you're playing them on a muddy field or on a glowing computer screen, share these exact same foundational elements.
So how exactly do we get those rules and characters inside the computer? Well, that brings us to a crucial definition. A program is simply a series of instructions that have been translated into a language the machine actually understands. The chapter uses a perfect analogy for this. Coding is literally just learning a new language. When you tap a button on your phone and an animated character jumps, that tap is just being translated into instructions. Programmers? They're really just people who figured out how to speak to devices.
Section 2. Visual Programming with Scratch.
Now that we know we need to speak the computer's language, what tool are we going to use to do it? The chapter introduces this incredibly accessible tool built exactly for this purpose. It's called Scratch. Now, don't sweat it if you haven't seen the Scratch interface before. It's pretty intuitive. You've got the stage, that's where all the action happens, where your game actually lives and breathes. Below that are your sprites, which is just a fun word for your characters or objects. And right there in the middle is the scripting area. That's your canvas. This visual layout is a total game changer because it takes these abstract coding concepts and anchors them into a real, easy-to-navigate workspace.
The really cool part is why we use Scratch. It's what's known as a visual programming language. So instead of typing out endless lines of complicated text, like you'd see in Python or C++, visual programming lets you move actual blocks of instructions. You literally snap them together, kind of like digital Lego pieces. It totally takes away the stress of making a random typo and lets you focus completely on the logic and the creativity of building your game.
Section 3. Designing your game. Plan before you code.
Okay, before you even touch a single block of code, you need a game plan, a brainstorming checklist. First up, you plan the details. Then you build your characters, your sprites. Are you going to use the built-in ones or draw your own from scratch? Next, choose your backdrop. Are we talking outer space, deep under the sea? And finally, determine the rules. How do your characters actually interact with each other? Following this step-by-step design process ensures that when you do sit down to code, you know exactly what you're trying to build. No guessing required.
Section 4. Coding, testing, and sharing. Testing your game.
Now we hit the really fun part, the active trial phase, where that carefully planned design actually turns into a functioning program. The curriculum gives us a really solid, structured approach to writing a script in Scratch. You start by bringing your characters and scenes to life. Then, you animate those characters using motion blocks. Next up, add some dialogue and text so they can communicate. Step 4 is absolutely crucial, using event blocks to trigger actions. For example, when the spacebar is pressed, make the character jump. And finally, you throw in some sound blocks to add background music and really polish up the whole experience.
But let's be real, it rarely works perfectly the first time around. We've all felt that quiet frustration of clicking play, only to watch our digital character walk backwards through a solid wall. The text asks a fantastic question here.
Are there any issues or bugs that need to be removed for smooth working? I absolutely love this because it totally normalizes making mistakes. Hitting a bug isn't a failure. It's a completely natural, expected part of the creator's journey. Testing your game, finding out what's broken, and figuring out how to fix it, honestly, that's where the real learning happens.
Once you've squashed all those bugs, it's time for sharing. This chapter puts a massive emphasis on sharing your projects. Think about it. When you ask your friends or group members to play your game, you have to explain the rules to them. You might even need to write down some basic instructions. Teaching someone else how your game works is literally the best way to reinforce your own understanding. Plus, seeing how your classmates tackle their coding can spark entirely new ideas for your next big project.
Section 5, Health and Screen Time, Finding Balance.
Now, we need to acknowledge a super vital contrast here. On one hand, we've got the incredibly engaging, highly focused world of Scratch programming. You can easily get lost in it. But, on the other hand, we have to highlight the absolute need to stay fit, eat healthy, take breaks, and talk about your feelings. It's all about balancing code and care. Being a great programmer isn't just about staring at a glowing screen for hours on end. It is equally about taking care of your physical and mental health.
The text actually lays out some really specific guidelines for this. Before you even start coding, it recommends discussing internet safety with your teachers and creating clear to-do and not-to-do lists. It's very explicit about this. Anything done in excess just isn't good, and way too much screen time can genuinely harm your physical and mental well-being. A truly great programmer knows exactly when it's time to step away from the keyboard, go play outside, play some sports, and keep that crucial balance between body and mind.
And that brings us to one final, vital question to wrap up everything we've talked about today. How will you balance your digital creations with your real-world well-being as you start your own creator's journey? You've got the knowledge now. You know how to communicate with computers, design amazing games, and code them using visual blocks. But honestly, your absolute greatest creation is going to be the healthy, balanced habits you build along the way. I really hope this explainer has left you inspired to get out there, start creating, and share your ideas. Thanks so much for hanging out with me, and happy coding!